We want to look at another method of solving simultaneous equation, simultaneous linear equation, and that is the Gauss Seidel's method. How do we apply this method? This method is an iterative method used for solving simultaneous linear equation. The method, let me just give you a clue about how the method works. It's a method where firstly, the first step to do you might use it to solve a simultaneous linear equation of about 3 variables or less or more, provided you know how you get to do things, or you solve three linear equations together with 3 different variables or 2. So how do we 3 variables? I mean, not different variables. 3 variables, and you can actually solve 4 equations together with this method. And it's unlike the elimination method, substitution method, inverse matrix, and Cramer's rule we have done. Gauss Seidel method is another method of which is very, very good, and it's close to them. It's very, very, let's say, it's also close and almost accurate way or method of solving simultaneous equation. How do we apply it? It's an iterative method whereby we firstly make an assumption of solutions. Is either you make an assumption or the assumption is given to you in the question. You make an assumption for the solutions of the variables you are about to find. So as a result of that assumption, then you work on it. You make first iteration, second iteration, third iteration, depending on what the question asks you to do. If the question says 2 iteration, so you're going to perform only 2 iteration. It's an iterative method. Anyway, when we start solving a question, I think we get it better on how it is solved. So let's look at the question and see how the method is being applied. We have a question here that says, so let's take this. We want to look at the Gauss Seidel's method. So that's what we got to look at today. So now the question says solve 12 of x plus 3y minus 5z all equals 1. And we have x plus 5y plus 3z all equals 28. Then we have the third equation, which is 3x plus 7y plus 13z all equals 76. So now the question gives us its own assumption. Mostly the assumption made when you want to solve this question is always that x, y, z are 0. So those are major assumptions made, but you sometimes might come across question that the assumption must have been given to you that starting from x equals this. So that's starting point. We call it an assumption or a guess. So now let's go along with this. The question says find x, y, z. Solve this after 2 iterations. So definitely we are going to perform 2 iterations in this question. And what iteration means, by the time we start solving, we will get it better. So now let's look at it starting from x, y, z equals 1, 0, 1. This is the assumption. But in most cases, when you want to solve this question and the assumption or the starting point of assumption is not given to you, then you can use a guess of 0, 0, 0, or probably you can make a guess on your own, but mostly the guess is always 0, 0, 0. So how can we apply this method in solving this question? Firstly, the first thing you need to do is that this is equation 1. You make x the subject of formula in equation 1. Then we're going to have so we have 12x plus 13y minus 5z all equals 1. So meaning I'm going to have 1 minus 3y plus 5z all over 12 all equals x. So bringing this and this to the other side, the positive sign changes to negative, while this changes to positive. Then divide all through by 12. I have this. I already make x the subject of formula with the first equation. So in the second equation, you can make y the subject of the formula. So we have x plus 5y plus 3z all equals 28. So here I'm going to have y equals 28 minus x minus 3z all over 5. So here I've made y the subject of the formula. Then the third variable will be made the subject of the formula in the third equation. Even if it is two equations, definitely you're going to have two variables. So but if it's three equations, it can accommodate more than two variables. So now that's this first step. We have not started an iteration at all. So we are just taking the first step of the method. So now we have 3x plus 7y plus 13z all equals 76. So meaning z is going to give us 76 minus 3x minus 7y all over 3. Oh, sorry. All over 13. 76 minus 3x minus 7y all over 13. I've made my points clear. I think I've made my points clear here. So now we can start the first iteration because the question asks us to perform just two iterations. So if the question requires more than two, we're going to do more than two. But we want to look at the solution of x, y, z after two iterations. And don't forget, this is our first assumption or guess. So this is how Gauss Seidel method works. So let's proceed to the first iteration. Iteration 1. Let's put it this way. The first iteration. How are we going to apply the first iteration? Here I have to make x. X already is the subject of the formula here. So I have x equals 1 minus 3y plus 5z all equals all over 12, I mean. So then the assumed value of y here is 0 and the assumed value for z is 1. So I substitute it here to find the value of x. Don't forget we didn't use this. So now we have x equals 1 minus 3 into bracket 0 plus 5 into bracket what? 1 all over 12. So that gives us 1 minus 0 plus 5 all over 12. And that gives us what? 6 all over 12. Yeah, 6 all over 12. Then we have that's 0.5. Leaving it in decimal, we have 0.5 because 1 over 2 is equivalent to 0.5. Because once I have 6 here, all over 12 is going to give me 1 over 2. And 1 over 2 is equivalent to 0.5. So I think I have to make the point clear in that perspective. So this is the first new value for x. This is the old value. And this is the first new value for x. Yet we are yet to be through with the first iteration. So let's continue. We do the same thing to all, but however, we are not using this value for x when we're substituting x and y. We are using the new value. We are not going to use the old value of x in the substitution of y and z. We are using the new value. That is the iteration. The iteration implies that the solutions are acting over each other. So now let's go. I will have to manage it like this just to be able to get access to the question. So you need to permit me to do that. So now the solution still continues. So then don't forget I will have my y also to be 28 minus, then I'm going to have 0.5 and not 1. So then I have 0.5 minus 3 into bracket z. Z is 1. We still have to move the 1 here. So we have 1. That's this. So all over 5. So if that is the case, let's make use of our calculator. to evaluate these values. And we have 28 minus 0.5 minus 3. So all gives 24.5 divided by 5. So that gives me 4.9. So meaning I have y equals 4.9. So this is the value for y, the first new value for y. While we still perform the first iteration. So let's get rid of this. So we go to find the value of z, which is 76 minus 3 into bracket 0.5 minus 7. Now I'm not using the old value of y, I'm using the new value of y. So I have 4.9 all over 13. So that gives me 76 minus 1.5, because 3 times 0.5 is 1.5. It's 1.5. So we have 76 minus 1.5. Okay, however, we have 7 times 4.9. So that gives us 34.3. So we have 76 minus 1.5 minus 34.3. So and that gives me 40.2. Anyway, the answer is supposed to be given in more than one decimal place, at least at least 3 decimal place, at least. But here I think we can just add 0 since the calculator is not giving us what we want in decimal, just to move closer to the accurate answer. So now we have actually gotten the solution for the first iteration. So this is, don't forget the old value, or let's say the assumed value, or the old value is 101. Now after the first iteration, we got x to be 0.5, and we got y to be 4.9, and we got z to be what? 40.2. So this is the solution for the first iteration. The more you perform, there's something I want you to understand in this method. The more you perform the iteration, the more you move closer to the exact answer. That is just what this method is talking about. However, you might be thinking that, okay, why can't we use every other method that will give us our answer straight? This method has an application, most especially in the engineering aspect. So that is why the need to talk about it is required. So now we have just finished the first iteration. So if we are meant to stop at first iteration, then this will be the solution to x, y, z after first iteration. So we can perform second iteration now. And to perform second iteration, we are not going to use this assumed value again. We are going to use the first values, the first iteration values. So now let's take that for the second iteration. So to start the second iteration, we already have whatever we need there. So however, we can still, okay, let's take it, the second iteration. So let's go. X is, I think I make x the substitute formula. So here we're going to have 1 minus 3y plus 5z all over 12. So we can go. We are going to use the value of the second iteration. So we're going to have x equals 1 minus 3 into bracket 4.9 plus 5 into brackets, z is now 40.2 all over 12. So we go 3 times 4.9, that's 14.7. So I have 1 minus 14.7 all plus 5 multiplied by 40.2. So that gives me 201. By evaluating all together, so we have 1 minus 14.7 all plus 201. So I have 187, all divided by 12. So the value of x here is 15.608 in 3 decimal places for the second iteration. So then we go to this to the value of z, to the value of y and z. Sorry, I have to rewrite this. So I have the second iteration, we have the value to be 0 0.5, 4.9, then 40.2. Sorry, permit me to do that. So we go to the value of y. So y is 28 minus x minus 3z all over 5. So that will give me 28 minus, and I'm using this value. So that's 15.608 minus 3 into bracket z. We still use 40.2. 40.2. So that gives all over 5. I think 5, yeah. 5. So we go 3 times 40.2. So that gives us 120.6. So then we have 28 minus 15.608 minus 120.8. So that gives minus 108.408, all divided by 5. So I'm going to have y, so it equals to minus 21.682 in 3 decimal place. So then we go to the final value of x. So that's the second iteration. So the value of z is 76 minus 3x minus 7y all over 13. So then I have 76 minus 3 into bracket 15.608 minus 7 into bracket. The value of y is now minus 21.682 all over value of z all over 13. So then I go 15, that will be 76 minus 3 times 15.608. So that gives a 46.824 plus, because negative multiplying negative gives positive. So we go 7 times 21.682. So that gives us 151.774. The addition of everything divided by 13. So we have 76 minus 46.824 all plus 151.774. So that gives 180.95 all divided by 13. So we have 13.919. So after the second iteration, the value of x, y, z. So after the second iteration is, we have the assumed value, the old value, to be 101. After first iteration, we have the value to be 0.5, 4.9, and 40.2. So after the second iteration, we have the value to be, for x, I have 15.608. For y, I have minus 21.628. Then for z, I have 13.919. So this method is just application in, it has application in some part in engineering courses. So, and that is how it is being performed. The iteration, the more you perform the iteration, the more you move closer to the accurate answer. So that is what this method is talking about. Thanks for watching. Please subscribe and share our videos. Thank you.